It's more force.
More force pushing against it.
Yeah, the further you compress it, the more force there is. But what we're saying is that the force is directly, another way to say this is the force is directly related to how far you compress it.
Okay.
If like this, let me put the numbers on here. So let's say the force is equal to 2 newtons for this spring. So if you compress it 1 meter, this is a big spring, 1 meter, and you get 2 newtons, then we know at 2 meters the force is what? 4 newtons. It's linear.
Okay.
And that most springs behave that way within a certain range. You get too far, and that doesn't work. And generally, that's the point where you start getting permanent deformation. Okay, so that's what this K. So that's newtons per meter. That's called the spring coefficient, or sometimes we call it the spring constant. So you have to know that for a given spring. Some springs are hard to compress. Some are easy. If you're talking about the car, springs in the back of the car, you know, I don't know, hundreds of newtons or thousands of newtons per meter. They're very stiff. Spring my ballpoint pen, not so much. So that's how stiff they are. That's defined by the spring coefficient. Okay. So let's work a little sample thing. Let's say our spring coefficient is 500 newtons per meter, and we're going to compress 0.5 meters from the relaxed state. How much work is done on the spring? I can answer this question a couple of days. I can say how much work is done on the spring, or I can say how much energy am I putting into the spring. It's saying the same thing. It's just a different way of saying the same thing. So to draw a picture of this, I'll just borrow this picture here. We've got our K, and we're going from 0 to 0.5 meters. So this is just pretty much plug and chug. It's 1/2 K, that's 500 newtons per meter squared, times 0.5 meter squared. So 25% of 500 is what, 125 times a half, 62.5. Somebody can correct me if I'm wrong, please. 62.5 joules.
Yes.
Okay, thank you. Let's just use some common sense here. We got this spring, and I moved it forward a meter. That was a certain amount of work to do that. Does it mean more or less work to do that next half a meter?
More work.
More work? Why? It's force times distance ultimately. So it's harder to press. It just keeps getting harder and harder and harder and harder and harder. So the further you go. So I had to define where I was starting from the relaxed state. If I change this, I'm going to change this question. I'm going to work it again. I want to compress from 0.5 meters to 1.0 meter compressed. So in this next part of it, I'm starting here, and I'm going to here. So this is my start, and this is my end. So I already said it's going to be more. It's going to be twice as much, more than twice as much. What do you think? Guess? More than twice as much. That's my guess.
So what would you do? Figure out both the distances and then subtract one from the other?
You can't do that because 1 minus 0.5 is